Welcome to qnawire.
We are taught that cobalt Br4 2 minus has landmarks of absorption at 3.4 times 10 raised to the power minus 6 meters, while cobalt Br6 4 minus also absorb, but we are asked that will the wavelength of absorption of cobalt Br6 4 minus be higher, be longer or shorter than the 3.4 times 10 to the power minus 6 meter that was observed in the cobalt Br42 minus. Okay, so in both cases, the oxidation state of cobalt is +2, so we have cobalt 2 plus. And the ligands are the same, bromine and bromide and bromide ligands. But the difference is the number of ligands attached to the metal ion. In the first case, we have a 4 bromide ligand, and in the second case, we have a 6 bromide ligand. And that determines the geometry of the two compounds. Right here, we have a cobalt Br4 having a tetrahedral geometry. So here we have a tetrahedral geometry. And in this particular case with 6 bromide ligand, we have a octahedral geometry. Okay. So one thing to know is that the energy of tetrahedral geometry is 4/9 that of octahedral. So tetrahedral is 4/9 delta naught. Okay, so that means that the energy of absorption in the tetrahedral complex is lower than that of the octahedral complex by 4/9. Okay, and we know that E is equals to hc over lambda. So we already established that the energy of tetrahedral is lower than that of octahedral. So this we have lower energy of absorption compared to this. So energy and wavelength are inversely proportional. So if energy is high, wavelength is going to be low. And if energy is low, wavelength is going to be high. So this having a lower energy, we have a longer wavelength. Okay, so this is going to be longer wavelength, lower energy, and this should have a shorter wavelength and higher energy, right? So that's it. So the wavelength landmarks for this will be lower than 3.4 times 10 raised to the power minus 6 meter.